going to do this up here. Programming languages. And we'll do this over here. Won't give this much. Lots of space. Areas of linguistics. And then in the middle we have methods and approaches. Okay. Now, the idea here is we can take this, we can map it onto something here, and we can take something from here, and we map it onto something here. Okay? Now let's start with the easy side. Here we've been doing Python using the NLTK. Okay? So, you know, when I was doing this as a computational linguistics class, they had Perl and Prolog. You guys have it a lot easier. All right. Okay, areas of linguistics. Phonology. Word morphology. Syntax. Semantics. And then pragmatics. And then we'll put discourse together. Okay, now, obviously what you need to be able to do is you need to be able to intelligently recognize what each one of these is. Okay, because, you know, there are going to be different methods that might be opposite to these. That might be appropriate to each one of these. Okay, so obviously, you know, you're going to have to know what syntax is about to talk to me and tell me about what methods are appropriate. I mean, for example, you know, certain methods might be used in all of these. And we'll talk about that in just a minute. Now, some of the methods are highly generalizable. Some of them are very, very specific. She showed off. Okay, that would have made your semester, I think. You're going to come and go, you know, as you please. Okay, so methods and approaches. So you need to know substantively what each one of these is, otherwise you can't talk intelligently about methods and approaches. So let's go through and let's start talking about methods and approaches. Let's start listing them. Okay, you guys know one. Okay, I keep talking about this, set theory. Really? Now, every group I do different things with. And we had a lot of linguists in here, and so what I wanted to do was actually kind of turn you guys on and get you thinking about sets, okay? Because I think that's a very important way for us to talk about programming languages of various types. Okay, so set theory is very important. Now, another area of methods and approaches, okay, so these would be more generalized, okay, would be logics. Oops. Okay, and then we've talked about three in particular. Okay, we've talked about propositional, predicate, and modal. Remember, modalities are using necessity and things like that. Modal logics are discussed in the Bach book. Okay, so we have, you know, various forms of logistics which can do some of the work for us. Okay, then we've got statistical, probabilistic. Okay, we have statistical probabilistic. These can all, you know, serve to, you know, provide statistics. Could be simple as text analysis. Probabilistic could be things like predicting whether or not a particular part of speech belongs in a particular category. Okay, so we got statistical probabilistics, we have logics. Okay, now more specialized things. Okay, we can think of lambda calculi. Which is basically an overarching theory of functions, which can describe various aspects of natural language to us. Okay, so we have lambda calculus. Then we've got other sorts of things which can help us out in various ways. Okay, we've got regular expressions. You know, which can define regular languages of various types. Okay, and then we have, you know, things like context-free grammars. Okay, so we have things like context-free grammars that also, you know, can help us out in a lot of different ways. Okay, so we have, you know, we have at our disposal set theory, logic, predicate modal, statistical probabilistic methods. We've got lambda calculus, regular expressions, context-free grammars. Now, these are some general, okay, general approaches. Okay, let's go into further elaborations. Now, let's think about sets for a minute. Let's start at the top. You know, one of the things that set theory does is that set theory leads to systems of typing and categorization. Okay? Systems of typing and categorization. And so when you describe a set, actually you're saying that all things in a particular set are of a particular type. The typing has been a fundamental thing that we've looked at all through this semester. All right, that we've looked at, you know, types as parts of speech. We've looked at types of various types of regular expression operators. We've looked at types as a way for us to even tag things like contextual dependency theory, things like that in Montague grammar. So, I mean, when we think about systems of types and categorization, okay, let's break this out a little bit. Just some examples here. POS, okay. In a sense, Montague grammar has a system of typing in it and models, okay. Montague grammar fits right in over here. And also Montague grammar, oh, by the way, will come in over here as well. Okay, but I think in general, I think, you know, Montague appreciated the importance of set theory as being very, very important for thinking about language in a particular way. Okay, and of course, you know, we can think of contextual dependency theory. It's just some over here. I'm just giving you examples. Okay, now, but you should be able to make all the big moves over here. Okay, you should be able to make all the big moves over here, you know, in that first column. And I know you guys can all do that. Okay, but you should definitely know to make those particular big moves. Okay, now, any questions so far? Now, one of the things that we're concerned with respect to logics, okay, so you can think of set theory as providing a way for us to talk about the world in a series of types, okay? What logics do, among other things, is this. These give us structure. Okay, now an important aspect I'm going to put further elaborations and aspects down there. Now, one of the things we need to think about with respect to predicate logic, okay, is that what predicate logic does, let's do this over here, okay, that predicate logic breaks down expressions into their atomic elements, you know, using predicates and quantifiers. Okay, so one of the things that predicate logic does is this gives us a route to semantics, to, of course, the principle of compositionality. principle of compositionality. Okay, that we are able to break something down into its compositional elements, and then we're able to test this against the real world. Okay, and so ultimately, what the principle of compositional logic does is this allows expressions of testing for allowing for testing of reference expressed in truth conditions. Okay, now, by the way, propositional logic also has truth conditions, but because your element that you're looking at in the form of a proposition, it's always in the form of a sentence. So you can't get that fine-grained analysis that you can get with respect to with predicate logic. Okay. Again, one of the things you've got to really pay attention to with respect to logics are okay, how well can these represent the structure of natural language? So we need to always keep that comment here, because propositional logic, because we're working at the level of propositions, doesn't represent things as well. They're not as expressive in terms of articulation as predicate logic. Okay, so certainly, what we can't get with propositions is really a fine-grained analysis of the constituents of a particular sentence, whereas with predicate logic we can. Okay, now with respect to modal logic. Now, modal logic adds on to all, or can add on. Now, there's propositional modal logic, and there's also predicate modal logic. Okay, that when you take the idea of a modal, okay, so a modal is think of it as an added function. Okay, this gives us another functional add-on which allows for greater ability to capture the structure of natural language. Okay, and so a lot of people feel that modal logics are really a pretty good way of capturing a lot of the dynamics and a lot of the finer structure, I should say, of natural language processing. Okay, now let's look at statistical probabilistic kinds of things. Okay, I could go on about logic for a long time, but I want to make sure that we cover, some of these things. Okay, statistical probabilistic. This has a large layer of applications. Okay, this goes, first of all, our descriptive. Analysis of texts. A lot of you are doing this. And here we're talking about text mining. Okay, so descriptive analysis of text. And this has a lot of different features. Remember, we got, things like length, concordance, lexical diversity, etc. Okay? And again, one of the things that we should associate, by the way, with statistical probabilistic, by the way, is use of corpora. Okay? So the use of corpora are very important with the statistical probabilistic, because what you're doing is you're running statistics on data. You're running statistics on data. And what are those data? Linguistics corpora. Okay, so put the corpora in right there. You know that largely, you can use corpora with logic. You obviously use corpora with set theory. But the place that we mostly think of the use of corpora is with statistical probabilistic kinds of things. Okay, let's go on with respect to some of these aspects. Now, the other things we can think of is things like part-of-speech tagging. Okay, certainly can be statistical. But remember, this can also be rule-based. Okay, it can also be rule-based as well. All right. And again, you guys have used a lot of these quite, in various ways. Also, you can think of statistics as being part of sentiment analysis, which you guys saw. Okay, that with sentiment analysis, what you're doing is you're measuring probabilities against, the Twitter API or the Twitter data, and it's trying to detect positive or negative sentiment with respect to sentiment analysis. That's something else. We've talked about, you might want to know this, okay, the importance of this. Some of you are actually using sentiment analysis with respect to some of your projects, okay, and it's, again, so this right here, part-of-speech tagging is really a morphological kind of thing. Sentiment analysis actually deals with pragmatics and a lot of those. And a lot of work that's being done with pragmatics and discourse uses statistical probabilistic kinds of things where you're doing descriptive analysis of text. Okay, because you're using corpora and those kinds of things. Okay, now, along to calculus. Okay. Logic calculus is a generalized theory of functions, okay, in one way of thinking about it. And for this course, what I want you really to focus on are the ways in which it can be thought of for function argument forms. And remember, with function argument forms, what we're doing is we're taking a general property, and in many ways, function argument forms can be related to set theory, okay, that with respect to a particular function, you're identifying that language consists of particular functions, and that when we talk about the form of a particular sentence, that we are talking about what could be plugged into that sentence. Okay? Regular expressions. Okay? These are basically, you can think of these as, for this course, think in terms of search patterns. That can define a language. Okay, and here we are going back to the day before spring break. Think of sheep, which some of you put into your last test. Think of sheep talk. Yes. Okay, so one of the things that search patterns do is that it allows us to search, and I want to say here, and further is, of course, the Porter-Stimeo. Oh, yeah, okay, fine. Part of stemming out. Okay? And again, part of speech check. Okay, good. I have that. Go ahead, up there. So what did I do with it? Okay. Part of stemming out. Okay, so this is a practical extension. Okay. Like regular expressions, yes?
Oh, what areas of linguistics would you say that regular expressions corresponds the most to? There we go.
Thank you. In this course. Now, Christopher, we could run an entire course on regular languages. And so it then would take in everything. That a regular language, actually what a regular language does, a regular expression expresses a finite state machine. Okay, and a finite state machine can characterize an entire set of strings in that finite state. And what happens then is it becomes a kind of generative grammar. I haven't talked as much about that because I can only focus on certain things, and this is very much a kind of practical course in theory and practice with respect to computational linguistics. So I would put the caveat that this equals relationship for I might try to emphasize something different next year. So this would be emphasizing relationship that when you see those dots, that equals a relationship for COG 376 spring 2015. Okay? All right. How are we doing? Pardon me? Don't, not yet. I'm not done.
Okay. All right, just before you erase anything.
I'm not going to erase. I was just going to erase this line. I'm not going to erase anything. I'm going to keep the board up here so you can take the picture. What I was going to do is I just want to do this. I want to have some extra room. That was all I did. Okay, sorry. Okay, now, let's talk about context-free grammars. Okay, these also now, again, you can use all of these for various things. So getting back to your question, Christopher, I would say, okay, mostly, but all of these overlap, okay? But the way I presented them is to kind of align with these, okay? That's the weight, okay? Weighted relationship, I should put this, weighted relationship. Let's be precise. Weighted relationship, because I could use any of these. And of course, by the way, set theory you get the picture. Okay? So you go down to all of these, okay, from set theory. Okay, I've never done it quite like this before. That's why I like to do this every year, because I come up with other kinds of amazing. Okay, so generative, that is they can define and generate a language. But they also, I'm just going to erase this, Jamie, I'm going to just move this down. I'm going to put this, oh, ouch. I'm getting old. You hear my knees crack?
Yeah.
It's getting old, oh man. Long way, Dr. Chambers. Okay. In the middle of the night. Talks to me. She does. Honey, I'm reading this article. What do you think about the normative aspects of this particular position? How can it be logically defined? Come on, baby. Okay. Anyway, and I get right in there with her. Okay. Anyway, that okay. that during a language kind of, oh, there's something, I'm sorry, and determine the grammaticality of the screen. Oh. Okay. Okay. And then this, of course, a further elaboration are, of course, feature structures. Okay, and this allows for a finer grained I wish I was taking this test. I really envy you guys. I do! Just stop it. You guys get all the fun. Okay. Now, with respect to these, okay, with respect to Python using the NLTK, let me number these. 1, 2, 3, 4, 5, 6. Okay. These methods. Because remember what we're doing here. Okay, look what I just did. But again, you could expand this. I'd like to see you think about more. Okay, I showed you the relationships here between this and this. Then the question is, what's the relationships between this and this? Okay, so one set theory is implicitly represented. Because set theory, you know, governs a lot of what we do. 2, logics. Implicitly or explicitly represented within the LTK?
Explicitly?
Good. Good, because that's chapter 10. That's why I had you guys look at that. Excellent. 3. Okay, statistical probability. Okay, what would you say? With what I have here, but okay, with what we have here, meaning these 3 things, okay, yes, they can be represented. Okay, and by the way, with respect to statistical probabilistic, You may also, again, with respect to part of speech tagging and feature structures, machine learning and feature extraction also part of this. Okay. So there are, just take my word for it, probabilistic linguistics that are not in the NLTK, huge areas. Okay? But what we have here, we're A-OK, okie dokie. Okay, 4. Lambda can be explicitly represented. We didn't talk about how to do that, but it can be. 5. Regular expressions, explicitly represented. And 6, context-free grammars, explicitly represented. Okay. So what we covered in this class, what I tried to do was I covered things which we could represent in the natural language toolkit very clearly, areas and methods of linguistics. And why I kept hammering home with set theory all the time is that behind a lot of these are set theoretic ideas, So that's why I wanted to emphasize those particular points. Okay? So there you got a study guide for the whole class, okay? If somebody would like to take a picture of it, whoa.